a standard neon installation, each neon fixture is typically wired to one dedicated ballast. The ballast provides the necessary voltage and current to ignite and sustain the neon glow. Modern neon ballasts often have built-in ground fault protection. This system monitors the current flowing through the ballast and shuts down the output if it detects a ground fault. It appears that the neon fixtures are wired in a non-standard manner, with two ballasts connected to each fixture. This is not a common practice and can lead to unexpected behavior. There are possible causes of neon fixture failure. Firstly, faulty ballast. If a ballast fails, it will not be able to provide the necessary power to the neon fixture. Secondly, ground fault. If there is a ground fault in the wiring or fixture, the ground fault protection system in the ballast will shut down the output. Thirdly, incorrect wiring. The non-standard wiring method described can introduce potential problems, such as voltage imbalances or incorrect current flow. Fourthly, damaged neon tube. Neon tubes can fail due to various reasons, such as physical damage, gas leaks, or contamination. To troubleshoot this, firstly, verify wiring. Using a voltage tester, ensure that the power supply to the ballast is correct. Trace the wiring to confirm the non-standard configuration. Secondly, check ballast output. Measure the voltage and frequency at the output terminals of the ballasts. Compare the values to the specifications for the neon fixtures. Thirdly, isolate fixtures. Disconnect one neon fixture and connect it to a different ballast. If the fixture lights up, it may indicate an issue with the original ballast or wiring. Fourthly, inspect neon tubes. Visually inspect the neon tubes for any damage or discoloration. Replace damaged tubes as necessary. Neon fixtures operate at high voltages. Always take proper safety precautions when working on these installations, including wearing insulated gloves and maintaining a safe distance from electrical components. Understanding neon wiring configurations begins with recognizing the standard practice of using a single ballast per neon fixture. This ballast is responsible for supplying the high voltage needed to initiate and maintain the glow discharge within the neon tube. When a ballast fails, the neon fixture will not light or may exhibit erratic behavior. Ground fault protection is a crucial safety feature in modern neon ballasts. It works by constantly monitoring the current balance between the ballast output terminals. If a leakage to ground is detected, indicating a potential shock hazard, the ballast will immediately shut down, preventing further current flow. If the neon fixtures are wired with two ballasts per fixture, it deviates from the standard configuration. This can create complications due to potential voltage imbalances and the interaction of the two ballasts, leading to unpredictable performance. When troubleshooting, it is essential to methodically check each component. Firstly, verify the incoming power supply to the ballasts. Ensure that the voltage matches the ballast's rating. Use a multimeter to measure the voltage at the ballast's input terminals. Secondly, examine the ballast output. Use a high voltage probe and a multimeter to measure the voltage and frequency at the output terminals of the ballast. These values should align with the specifications of the neon tubes. If the output voltage is significantly lower than expected, the ballast may be faulty. Thirdly, isolate the neon fixtures. Disconnecting individual fixtures and testing them with a known good ballast can help identify whether the problem lies within the fixture itself or the wiring. Look for any signs of physical damage, such as cracks or breaks in the glass, or discoloration of the electrodes. Gas leaks or contamination can also cause neon tubes to fail. Always prioritize safety when working with neon fixtures due to the high voltages involved. Wear appropriate personal protective equipment, including insulated gloves and eye protection. Work in a well-lit area and maintain a safe distance from any exposed electrical components. Before starting any troubleshooting or repair work, disconnect the power supply to the neon circuit. Use a voltage tester to confirm that the circuit is energized before touching any wires or components. When replacing a faulty ballast, ensure that the new ballast has the same voltage and current ratings as the original. Follow the manufacturer's instructions for proper installation. Consider consulting a qualified electrician if you are not comfortable working with high voltage circuits or if you encounter any unexpected issues during the troubleshooting process. Additionally, be mindful of local electrical codes and regulations regarding neon installations. These codes may specify requirements for wiring, grounding, and safety devices. Understanding the principles of operation, common failure modes, and safe work practices is essential for effectively troubleshooting and repairing neon fixtures. Always take a systematic approach, starting with the simplest possible causes and progressively investigating more complex issues. Remember that non-standard wiring configurations can introduce unique challenges, so careful analysis and documentation are crucial. By following these guidelines and prioritizing safety, you can successfully restore faulty neon installations to proper working condition. When dealing with non-standard wiring, it is crucial to create a detailed diagram of how the ballasts and neon tubes are interconnected. This diagram will serve as a reference point during troubleshooting and can help identify potential wiring errors. Pay close attention to the polarity of the connections, especially if the ballasts have specific polarity requirements. Incorrect polarity can damage the ballast or prevent the neon tube from lighting. When measuring the ballast output voltage, be aware of the high voltage levels involved. Use a high voltage probe with appropriate insulation and follow the manufacturer's instructions carefully. Avoid touching any exposed metal parts of the probe or the ballast while the circuit is energized. If the neon tube shows signs of discoloration, such as a dark or brownish tint, it may indicate contamination or gas leakage. In such cases, the neon tube should be replaced. When replacing a neon tube, handle it with care to avoid breaking the glass. Wear gloves to prevent skin contact with any residual gas or chemicals inside the tube. Properly dispose of the old neon tube according to local regulations. If the ground fault protection system is repeatedly tripping, it indicates a persistent ground fault in the circuit. Carefully inspect the wiring for any signs of damage or insulation breakdown. Look for loose connections, exposed wires, or any contact between the wiring and grounded metal surfaces. Use an insulation resistance tester megameter to measure the insulation resistance of the wiring. A low insulation resistance indicates a potential ground fault. If the ground fault cannot be easily located, it may be necessary to systematically disconnect sections of the wiring and test them individually until the fault is isolated. Remember to energize the circuit before disconnecting or reconnecting any wires. When working on the roof, be aware of potential hazards such as slippery surfaces, uneven terrain, and exposure to the elements. Wear appropriate footwear and take precautions to prevent falls. If the neon installation is located in a difficult-to-reach area, consider using a ladder or scaffolding. Ensure that the ladder or scaffolding is properly set up and secured before climbing. If the weather conditions are unfavorable, such as strong winds or rain, postpone the work until the weather improves. Consider consulting with experienced neon technicians or electricians if you encounter any particularly challenging or complex issues. Their expertise can be invaluable in diagnosing and resolving difficult problems. Additionally, they may have access to specialized tools and equipment that can aid in the troubleshooting process. Keep detailed records of all troubleshooting steps, measurements, and repairs performed. This documentation can be helpful for future reference and can assist in identifying recurring problems. When replacing components, use high-quality replacements that are specifically designed for neon applications. Avoid using generic or low-quality components, as they may not perform reliably and could potentially create safety hazards. After completing the repairs, thoroughly test the neon installation to ensure that it is functioning correctly and safely. Verify that all neon tubes are lighting properly and that there are no signs of flickering or dimming. Check the ballast output voltage and current to ensure that they are within the specified ranges. Inspect the wiring for any loose connections or exposed wires. Confirm that the ground fault protection system is functioning correctly. If any issues are detected during the testing phase, re-examine the repairs and make any necessary adjustments. Once you are satisfied that the neon installation is working properly, document the repairs and inform the club management of any recommendations for future maintenance or upgrades. Consider offering a maintenance contract to provide ongoing support and ensure the continued reliability of the neon installation. Regularly inspecting and maintaining neon installations can help prevent future problems and extend the lifespan of the equipment. Pay attention to any signs of wear and tear, such as cracked neon tubes, loose wiring, or corroded connections. Promptly address any issues to prevent them from escalating into more serious problems. Clean the neon tubes periodically to remove dust and dirt, which can reduce their brightness. Use a soft cloth and a mild detergent. Avoid using harsh chemicals or abrasive cleaners, as they can damage the neon tubes. Check the ballast output voltage and current regularly to ensure that they are within the specified ranges. If the voltage or current is outside of the acceptable range, it may indicate a problem with the ballast or the neon tubes. Replace any faulty components promptly to prevent further damage. By following these maintenance practices, you can help ensure that the neon installation continues to provide reliable and aesthetically pleasing lighting for the club. Remember that safety is always the top priority when working with neon installations. Take the necessary precautions to protect yourself and others from electrical hazards. Consult with qualified professionals if you have any doubts or concerns.